Okay. Carlos, read for us the problem. You see it? Extra help 02 distance part 1. Okay. I want everyone at this table to take a good guess what numbers are going to be what on your paper. Write small, though, because you might have to change it. So look at the problem again. I'm going to print out my notes. Take a good guess what is the variable is going to represent. There's x's, there's v's, there's t's. Yeah. Yeah.
If 10% of 33 is 3.3, where is that being put in?
That's going to be your VF.
So it's not going to be 33, it's going to be 3.3.
Sorry, XF. It's going to be your XF. 33 plus 3.3 is 36.3. So put that there.
So 36.
Yes. All right. Because that's the equation. The equation is XF equals XI plus VIT plus half times AT. Yeah. All right, got the right notes this time. So, Caleb, what is one of those numbers representing? So, yeah, look at the problem. Like, what do you think 28 is going to be? 28. So that is the unit it's measured in, but for like our equation, it all goes back to the equation. What is the letter it's going to be representing? Say again. VI. Okay, so let's write this down. VI equals 28. But why, Elijah? Everyone see that? I'm going to underline it. So it's really nice, Caleb, when the problem will say what the letters are going to be. So everyone write VI equals 28 meters per second. Caleb, what does VI stand for? The initial velocity. Initial velocity. You just call it initial. Nice. Initial velocity. So let's draw a picture. Everyone draw a line. and this is where we want the car to stop. And here is where our car is moving at what Elijah said, 28 meters per second. Okay, next letter. Leah just got here, so Leah, we're now in Extra Help 02 Distance Part 1, if you want to follow along on a Chromebook. So Jesus is writing it down. So, Carlos, what is the next number that could be a variable? Negative 6.0 meters over seconds squared. So what variable will that be? Hey, how did you know? It has meters per second squared, and the problem says what? Acceleration of the car. Okay? How thoughtful of them to do that. Next variable, back to Caleb. Actually, we skipped Jesus. Jesus, what should this last number be? This 0.5s. How'd you know? What does S stand for? Seconds. Seconds are time. So there we have our known variables. And we're going to solve for an x, because it says stopping distance. Stopping distance. But which x is the question? Is it going to be xf, xi, or is it going to be a third kind of x? Okay, is it going to be a third kind of x? Let's look at our picture. When you have a driver in this car, they need to think to themselves, oh, hit the brake. Okay? But that takes time. Sure, it's short time. Some of you, when you drive, you're going to learn to brake like almost instantly. But you still need that tiny millisecond to actually say to yourself, brake, danger, police, right? The pedestrian. All these things can tell you that it's going to be time to brake, but that takes time. So with our picture, we're going to call half of it reaction time. Reaction time. And then once the person gets the foot on the brake, now the car has to slow down. Now, who's been to a takeover? I'm not going to tell you. I'm telling you. Who's ever been to a takeover? Seen it, okay? Why does the car slide? Momentum and speed, and the tires are not sticking, right? They're sliding, drifting. Okay? Eventually it stops, right? Eventually the cars stop. So that time, sometimes they break down, sometimes they crash, right? Unfortunately. But when those cars are sliding, it takes time for it to completely stop. That's the other half of our picture. Okay? So the car braking, and not breaking apart, but hitting the brakes. And then it finally stops. So I'm gonna do that. So we have to find two kinds of x. Not just xf, not just xi, but an x for the person to think about, I need to hit the brake, and then you need an x for with a car finally stopping. Okay, think of this as like the drift. Think of this as the person saying to themselves, hit the brake. So we're going to find two kinds of x's. We're going to find xrt, which is reaction time. So make a note for yourself. And then we need to find x little b. That's when the car is finally braking. Now, how did I know to do that? Someone taught me this. Okay, it's not something I expected you to figure out and to know all the whys. This is what is passed down, and once we learn the basics, we can start inventing our own stuff. But you have to first learn the foundational knowledge. Okay, we have quick question? Okay. Natalie, can you check on him? Thank you. So we have XRT. We have VI. We have V. Hello. Hey, Legos?
Yeah, dude.
Yeah, check them out. They're right there.
Okay.
And if you need a wagon, I have a wagon in the inventory.
Well, right now is my conference. I was thinking that let me take a look at them, and
Yeah.
I'll have my kids come and pick them up second period.
Perfect. Second period's a little crazy, but just fair warning. Like, it's going to be a little chaos. Thank you. All right. We're missing one variable for this problem, and it's going to be VF. We're missing one variable. We have VI, 28. We have A, we have T, we have everything else. Thank you.
I'll come second period.
Wonderful. Thank you, Mr. Geronimo. What is it going to be? Anyone know? Yeah. What's VF going to be? Why? Yeah. You want the car to stop. Cars don't have speed when they stop. So this is kind of like opposite of the previous problem. We want the car to get to the other side of the intersection. This car, we want it to stop. So now let's use an equation. Label your first X here, RT, and then label your second X, B. You have to combine the two to get the total distance for that car to completely stop. So we're going to use this equation. V equals change in X over change in T. Now, we haven't been using this triangle very often. Actually, I don't think we've ever used the triangle. So for now, just use what the letters provide you. But later on, you'll find out triangle means final minus initial. Final minus initial. You can make a note for that for yourself if you like. But we're not going to use that right now. All right, we need to solve for X. So let's go back to Caleb. Caleb, how do I get X by itself? Because I want to find X for this first one. So I want to find what X is for RT. So how do I move this to that side? What kind of math should I do? It's already being divided. We're going to, what's opposite of divide? Multiply. So let's go ahead and multiply delta T to both sides. And what's left over, Caleb? If I'm going to rewrite this whole thing, what is remaining? So another tough thing about physics is that my x's can look like multiplication. I'm trying to put like a little curve on each end of the x, so it's like an x, and then my multiplication, I'm trying to make them as straight as possible, so it's a multiplication. So there actually is no x on the left side. You could, as long as there's no number that has a decimal. Because sometimes you'll mistake, oh, the period is a multiplication symbol, so it just depends on the situation. Yeah, but I used to think the same thing, Devin. So what's left over, Caleb? There is a T, and it comes with a triangle, but it's multiplying with something.
What is the
Triangle means final minus initial. It's something we're going to use later, but for now you can just treat it as T by itself. You see this letter?
V?
Yeah, V. So V is multiplying to T. So we can say V times T equals what? What's left over? Yeah, triangle, but these two canceled out. Like this canceled out with that, and then this became that. So X, all right? X. Okay, plug in, Elijah. What is our V? .28. What's our T? 0.50 equals delta X. Aaliyah, do the math for us. .14 equals X. Now, Jesus, yeah, write that down. I'm going to ask Carlos, which X did we just find? Like, what do you think? Do you think we found XRT or XV? What do you think is a good guess here? Why? We use what numbers that tell us it's we use initial velocity and time. We did not use this acceleration. Because the acceleration, here's a new concept, can be speeding up or slowing down. Okay, write that down. Acceleration means speed up or slow down. Acceleration is speed up or slow down. How do you know if it's speeding up or slowing down? When acceleration is positive, it's speeding up. When it's slowing down, it's negative. So make that note for yourself. When acceleration is positive, it's speeding up. When it's negative, it's slowing down. Now, Carlos, if our acceleration is negative 6.0, is it speeding up or slowing down? It's slowing down. When did the car start to slow down? When the person is thinking or when the brake is hit? When the brake is hit. That's for later. We did not include the slowing down in this equation. So it has to be which X? XRT. So everyone write little rt. Okay? And I didn't expect you guys to know that. This was something that has to be taught because I was taught this way. Okay? So this is part 1 of our massive physics problem. Okay? Label this picture 14 meters. 14 meters. We're going to come back to this in part 2. So I'm going to pause recording.